Welcome to my third podcast on separable differential equations. In this one, we're going to be studying a differential equation which has a solution that is really very simple to memorize. And so while I'm going to derive it for you, I want you to keep in mind that the final form of the answer will always be the solution to this particular equation, where the initial value will change the value of k, where k is a constant, but these answers are still going to look the same. I'm still going to do the derivation for you, though. So doing the separation of variables gives me that dy over y is equal to k dt. So now, because I've separated the variables, I can do my integration, at which point I would get ln of y on the left side, and I would get kt plus c on the right side. Now, as you remember, to get rid of the natural log function, what I would do is I would make each side a power of e. So remember that right there, which gives me that e is equal to e to the kt plus c. But this is something that we'd like to rewrite to make it look a little more user-friendly. And so to do that, we actually break up the powers of e so that it's e to the kt times a power of e to the c power, which we then treat as its own constant. Some people use c sub 1, some people use c sub 0. I'll use c sub 0 times e to the kt. I want to remind everyone that this sometimes looks like this formula, which many students are familiar with from work in other courses. It's really the same formula, just slightly different variables being used. So in a problem like this, what you would normally then be given is you would be given either one of two things. You would either be given a value for k and then a point, which would allow you to establish the value of c sub 0, or you would actually be given two values, two ty ordered pairs, and you would use both of those to determine your other variables. It just kind of depends on the problem. I'm going to look at one where we're given the 2 points 0, 60 as the initial value, and then I will also look at the other one where I'm given that at 10 the y value is 30. Now, keep in mind, if I plug the 0 value in for t, it sets up that c sub 0 has to be equal to 60. All right, so that's pretty established. So I have a new model now, and my new model is y equals 60 times e to the kt power. My problem, however, is that I still need to know what k is equal to, because k is a constant. Well, to solve for that, I use the second point. So the second point tells me that y is equal to 30 times 60 e to the k, and t is going to be equal to 10. And so I merely need to go through the process of solving for k at this point. This isn't too difficult a problem. It might require some calculator work just to get a nice decimal. So let's work it out here, okay? So we're going to divide both sides by 60. So we're going to get 0.5 is equal to e to the 10k power. All right? Now, at this point, I can see that if I take the natural log of both sides, so maybe I can do some work here. So I'm going to get that ln of 0.5 is equal to 10k, right? And then if I multiply both sides by 10, I guess I would get something like 1/10 ln of 1/2 equaling k, and I could use a calculator to determine the approximate decimal value of that and plug that into my original solution, which is circled right here.